that will have to be used here pretty soon. So just going to kind of go over some information on frost, kind of how it forms, and maybe some of the ins and outs of how it could form maybe on in some areas, but maybe not in others. And then also open up the product to MDSS and maybe find some areas where you can kind of see some information about where and how you might get some alerts or et cetera on frost. So without further ado, let me share my screen here real quick. All right, so we're kind of talking road and bridge frost this morning. It is a little bit different. Bridges are a little more susceptible to the ambient air temperature because they don't have a subsurface like a road does. Road has a road base, especially this time of year. Well, that road's sitting on that warmer ground. It's built up all that heat throughout the summer. Probably going to prevent a lot of frost, especially in the fall, where maybe as we cool down some of these mornings, the bridge may be more susceptible to actually seeing frost. But how does frost form? One sec, let me forward my slide here. And really, the main thing with frost is it is looking for your dew point temperature to kind of become higher than the pavement temperature. So when the dew point temperature goes above the pavement temperature, that is when we see that frost to form. And it could be road and or bridge. It doesn't really matter, but we're looking at that dew point temperature getting warmer than the road temperature. Now, once again, we need that pavement to be, at freezing or below freezing for then frost to form. You wouldn't see frost forming on that roadway if the roadway temperature is like 34 degrees and the dew point's 35 or 36. You might see some moisture condensation on the road, but of course, because it's above freezing, you wouldn't see that frost form. But that is kind of truthfully what we're looking at. If we're not seeing that dew point temperature above the road temperature, frost will not form. So typical nights where we see that frost can form is when we see clear, calm conditions, so we can get a lot of radiational cooling. That's when we're going to lose the heat from the surface of the earth and the roadways and the bridges and such. So they lose a lot of their heat that they've built up throughout the daytime when we have, the sun out, even though maybe midwinter it's not a ton of heat, but they still do warm a little bit during the day if you can get some sun on those. So that's kind of the main nights that we are expecting frost. A lot of times when we have wind and the wind kind of mixes up the lowest layer of the atmosphere, so it tends to almost work as it kind of keeps it stirred up. It doesn't allow it to radiate and cool as much. So that's why we don't maybe see frost as much when we have windy situations. There are a few caveats to that. Sometimes when you have basically a really dry and cold air mass, say there was an Arctic air mass in the area, and now all of a sudden you get a quick return of maybe a warmer, more moist air mass. Just depending on how quickly that change can happen, sometimes you can see some frost build up in that situation. But generally, we're looking no wind or very little wind and clear nights. With clouds, you tend not to radiate that, and cool quite as much. That cloud acts like a blanket, so it's not as susceptible for frost when you have cloudy conditions either. So you're looking for clear, and cool nights, of course, pavement temperatures below freezing. So here's a little more of a, come on, there we go. This is the slide I want. So generally, kind of think of, here's kind of a real world example a little bit. It's evening time, clear, calm conditions. The dew point temperature is 27. We've got a pavement temperature at 30 degrees, and we've got a bridge temperature at 30 degrees. So at this point, frost isn't forming. We can see those pavement temperatures are still above that dew point temperature. As we go through the overnight, we start to cool things off. We see our dew point temperature really hasn't changed. It's still 27 degrees. The road temp cooled a little bit, down a degree, but we're still at 29. But as you can see, the bridge temperature has already dropped. It's radiated out. It's actually 25 degrees. So we can actually expect some frost to start to form on this bridge deck as, you know, we have cooled it off, so that bridge deck temperature is colder than the dew point temperature. Now here we see the road temperature, 29 degrees. So it's still warmer than that dew point. So we're not expecting frost to form, you know, on that roadway. At least at this point in time, it would still need to cool a few more degrees to then start that frost process. And even once you would maybe reach, let's say they were both, say that road temperature dropped to 27 degrees, dew point was 27, it would still take a little bit. It's not like all of a sudden the road is just gonna, boom, go icy, but this is when frost could start to develop. And, you know, the closer the dew point temperature and the road temperature are, let's say together, so they're basically equal, that frost is going to form slowly. If, you know, all of a sudden you would drop that road temperature down to 25, 24, you would see that frost build up a lot quicker, and it could be a lot thicker as well on the roadway. So becoming more slick quicker. So hold up, just forwarding to a few slides. Now, one other thing in the winter, if you have open water near that, either a bridge or maybe even, I guess, you know, along Lake Superior, you guys, you know, you have a lot of roadway that is near open water. That can cause some very local higher dew points. And they may not be measured by the RWIS if there's no RWIS there. So like Lake Superior along Highway 61, if you maybe have just a light breeze from the east where you could maybe get some of that air that was over the lake to push over that roadway, you could actually see local dew points where it does get higher than maybe that road temperature in certain situations. And so you could see some local frost that, once again, if not observed by an RWIS sensor, where we can, and that's where we're seeing our pavement data come from within the system, you could get those local effects. So it could be a bridge over water that does not freeze during the winter. You know, if you've got a fairly fast moving river or stream or something that does stay open during the winter, just right around that bridge, that could be let's say a bad spot. It's just, if you know maybe there's a chance of frost, it's probably elevated right over that bridge. And maybe as you move, you know, even a mile away, it's not going to affect it. It's going to be very hyper local to that open water. Generally, probably we think of it more over on a bridge over water, but once again, you know, you don't see a lot of Lake Michigan freezing up. So that's a big body of water there, And some of that relatively more moist air, it does push over land, could cause some hyperlocal frost conditions that even the MDSS system wouldn't pick up, because maybe an RWIS system is not picking it up kind of initially. Kind of another maybe thing to worry about, and this is especially kind of in District 1, it doesn't really affect more of the western and southern part of the state where we don't have a lot of trees, but especially as we get into the winter months where we have a very low sun angle, there can be spots on those roadways where you don't get maybe as much heating, where that road is shaded. So during the daytime, it doesn't warm quite as much. So the pavement temperature might be difference between where it's shaded and where it does get sun for a lot of the day. So it can kind of work in two ways. That section of pavement that's shaded could be just colder during the day, which then probably becomes colder during the night, and maybe that shaded area's more susceptible to having frost develop through the overnight hours. You can also look at it this way: if frost does form on that roadway, it's not going to get the sun in the morning as soon, and on an untreated roadway, that frost is going to last a lot longer. You kind of see that as well, where bridges may shade a road below, and that one little section that kind of never gets sun can always see a little bit more frost. Sometimes you just see a little ice build up in that one little section that's always shaded from a bridge deck on a roadway. Now, once again, a lot of the roads, the trees have been kind of cut back, so most of them do see sun a lot of the days, but you get into some areas in northeast Minnesota, and yeah, there are a lot of trees, and that can play into the frost, no frost. Go ahead, Michael.
Yeah, just particularly in the spring, man, it's a huge difference. If you get under a bridge spot or a shady spot, you have twice as much frost in those spots as you would where the sun's getting at it.
And it kind of goes back to the how the roadway is built, right? So in the fall, we've got all that heat built up in the road or in the subsurface through the summer months, and it takes a little bit to cool that down. So this time of year, as we're cooling down at night, well, the pavement temperatures tend to stay a little bit warmer because you got that heat still in the ground that helps to warm that roadway. Now think about it at the end of February, early March. Now you've cooled that sub base down. There's frost in the in that subsurface. So the road's sitting on a block of ice, but you're starting to bring in warmer air. Warmer air tends to have more moisture with it, embedded, so the dew points can become higher. But until you can get that road base warmed up, that's when you tend to see a lot more road frost. So in the fall, on average, bridge frost is more likely because the bridges can cool quicker with the changing of the temperatures. And then once we go into the springtime, it's actually the roadways that tend to see at least a better chance of frost, because the bridge decks will actually warm up a little bit quicker if the surrounding air does warm up. So it shouldn't say, I mean, there's always cases where you can say, well, that didn't happen. Yes, but kind of on average, we don't see a lot of road frost in the fall. We tend to see it more midwinter and into the spring after we've cooled off that base of what the road is built on. But shading can also play, a huge difference. And once again, if we're using RWIS, that's where we can get our pavement temperature into the modeled system. So, it might be where that Arwis is always in a sunny location, and maybe in some small shaded areas, it's not going to actually, come up with that we're going to expect some road frost tonight. But, shaded areas, sometimes valleys, low points in roadways, sometimes it just takes 1 degree or 2, just a little bit cooler or a little less sun during the day to help cause that frost. So as I mentioned, we look at kind of the dew point temperature, and the dew point is kind of a measure of moisture in the air. It's not quite that, but for all intents and purposes for this discussion, we'll kind of go with that. And it's basically is if you cooled the air to the dew point, that's when you can start to see dew to form on grass, etc. It condenses that water. We kind of always look at the dew point depression, which is the difference between the air temperature and the dew point. If that's a wide spread, we tend to say that the air mass is drier. If it's very close, we tend to say that the air mass is a little more moist. And that's kind of where the relative humidity comes into play. That is that percentage between the air temperature and the dew point temperature. So if we have high relative humidity values, close to 100%, there's a bit more moisture in the air than, if we say it was at 50%, that air would be a little bit drier. So it's the nights that we see, once again, cooling with those high relative humidity values, probably a better chance of some frost maybe developing, once again, as long as everything is cool enough for that. So, and kind of how we can use maybe dew point relative humidity a little bit. If you have a high relative humidity, you've got a better chance of seeing maybe fog in the area. If the pavement temperatures are cold, then when you get that fog, you could see some freezing fog. Now, sometimes freezing fog doesn't necessarily affect the roadways because basically it's considered a suspended water droplet, but it can, what we call accrete. That's where it kind of builds on like bridge surfaces. It usually affects more elevated surfaces over the roadways, but it still can cause some slick conditions where you can get that kind of hoarfrost built up on leaves, trees, branches, that type of stuff. It can, cause road frost as well, but usually road frost is more prevalent when you see the clear, calm conditions, because then the pavement can cool a little bit more. Once again, it's not really about the air temperature. It's more about the pavement temperature in respect to the dew point. But we do need cold conditions. That would be the one aspect of using the air temperatures, is just to make sure that we're relatively cold out there. All right, so that's kind of how frost forms, kind of just the true definition of frost, and where we may see some challenges in different areas of roadways where it could form, could not form. Now I'm going to kind of jump over to WebMDSS, and I'm going to just show you some places within the product itself where maybe we can find some information on where it may be frosty, how we could get a little bit of alerting from it. And so I'm logged into the MDSS system here, kind of looking at northern Minnesota. Let's see, I better share my screen again or you guys won't be able to follow along. There we go. So I'm logged in. I've got some alerts turned on up here, and I've turned on my road alerts, and I can see a little some risk of road frost, and these purple actually got one little lightly slushy route. So if I have my road alerts checked on, it's actually showing me areas that could potentially see some frost. Now with that, for those road alerts, due to how there's data set up or route configurations, I know in Minnesota that these won't trigger until at least 1 hour in the forecast has a 40% chance of frost developing for any given hour. That's how it's set up within the system. And just using it and looking at frost the whole time, 40% is probably the low end. Go ahead with your question, Michael.
I was just going to point out that I don't know if people understand how those alerts work, or if you zoom in on so your screen is only showing 4 routes. So our patrol folks could zoom in on their sub area, and then they're only going to see, if those boxes are colored, it's only going to be when there's an alert for on their particular roads during those hours. So I just wanted to point out that people can use the zoom to dial in what they're seeing in the alerts.
Correct. It's so I have my road alerts checked on here. There's one little check mark if you look up in the upper left. And as I zoomed in, or let me zoom back out again to catch some of these routes to our west, you see how the boxes changed. Now, once again, I'm looking at roads. If I had it switched to weather, then it would be, hey, if there's any weather in the area. But when I kind of focus in here way up on the northeast part of the state, you can see it changed where now we are just at maybe some risk of frost on just this one route. If I zoom out and actually let's go down to the southern part of the state, I just want to show where there is no chance of frost, as you can see. So it works dynamically to the location that you're seeing. If you're in the current view, I do want to explain one thing. It says statewide view here. So if I click that on way at the top, you'll notice that now I've kind of got all the alerts back for the statewide. Then it doesn't matter where I'm dragging and looking. It's always going to show me any alert throughout the state. Default is current view, so it's just what we're seeing within the map region here, and it's any given hour, so there's 24 hours, of course, and that's where you can see it. So couple of different ways that maybe we can see if there's any frost potential. And once again, usually for the most part happens early in the morning as we get to our coldest point, of the night. That's usually your best chance of frost forming. Once again, there are some caveats to that that we maybe won't really get into, but those that's the kind of best chance. So if I were to click on the route, we can actually see it's giving a little, hey, beware, precautionary, a risk of some frost out there. And probably it's because we see pretty cool pavement temperature on average. If I were to go into my table view, so this is where I can see that hour by hour forecast, and my blue line here is current, we can actually see that there is a frost probability with these forecasts. We can see it was kind of high here this morning, early morning hours, going or decreasing as we get some sun up there. We do have a recommendation to go out at kind of in that 6 to 10 a.m. time frame to at least go out and beware of that risk of frost. I want to kind of hover over this where it says dry. So we had some higher probs, and it isn't until maybe we see a little moisture develop on that roadway. We're kind of, pavement temp is a little bit warm here for frost, but it did kind of dip a little bit cooler, and that could be that the forecast was a little warm, but now it's starting to get data from an RWIS that says, hey, this road is a little bit cooler. But it's trying to develop a little bit of liquid on the road, which at that temperature may then turn into frost. Very borderline situation of what we're seeing right now. I wouldn't expect frost to be on this roadway, but I do want to go back into my map button up here, and we can see, so I've got all my little circles here. Those are the RWIS, and I've got it set to road temperature. So we're actually seeing here up by Grand Marais that the pavement temperature has actually dropped to 31 degrees. And if you look up here, we've got kind of a warm dew point, and that would kind of, play into that one RWIS could be seeing some frost based on the pavement temperature. Maybe that pavement temperature sensor is a little bad just looking at things. And that's probably kind of why it's such a borderline case. I think there is a little issue with that pavement sensor. I think it's reading a little too cold. But that would be what we were looking for. Cold or pavement temperature that's colder than the dew point in this column, and it should be putting out some frost. But once again, I think there is a little issue with that. It's reading a little cold, at least from what I could maybe tell. And especially, this is when you kind of go, okay, well, let me look at some other RWIS in the area. You go down to Grand Marais just a little bit. That pavement temperature is 38, which is probably closer in nature. So even within the system, we always kind of got to judge that the data coming in is actually, correct. And in that one, I think it's a little too cold, kind of maybe tricking the system just a little bit because it wants to use that pavement temperature to kind of initialize things, but probably running a little cold. I do want to kind of go out west just to kind of look at another segment and just using it for this potential for frost. And you can actually see when I click on a route, then it actually highlights maybe that there is some risk of frost. Once again, that's probably triggered because it reached that 40%. Sometimes it's a little bit lower, but at 40%, it'll actually say, well, I'm going to give a precautionary recommendation because it's reached that 40% mark. And that's kind of set up within the route configurations. There's a thing that we can kind of turn on and say, hey, once we get to that chance, let's start highlighting, bringing attention to it. Wouldn't maybe give a treatment recommendation, but it would say, things are potentially giving you some frost out on that roadway. So maybe at least go out and check it out, that kind of stuff. Once again, if I opened up the table, see the forecast for here, we can see that it's still dry, but if I hover over this dry, and earlier it was showing me that it could have a little light layer of frost. I'm not seeing that now, but I did. I'm going to drag over another image, and it's probably not going to come up. Yeah, it won't. But if you hovered over that, it was actually showing just a little bit, a very, very thin layer of frost that was going to be on the roadway. And that's where you can kind of see that in these layers. We'll actually try to give the depth of frost if some is expected. Once again, here in this precautionary type of situation, probably really not going to be frosty on the road, but there could be some. Yes, Michael.
Could you just mention that how the forecasts are dynamic, and if they come in at the beginning of the shift at 11 p.m. and check it, it may or may not be different at 4 a.m., for instance, if something changes in the forecast.
Right. Our forecasts update basically about every hour. They can actually update sooner, but it's about once an hour. And it's because we're always getting new data in, especially we're getting data in from the roadway, and sometimes if even the trucks are out there from the AVL units that are within the truck collecting data, that gets fed into the system. So as you can see here as well, if I hover over this where it says dry, you can see because of an RWIS observation that we're getting. So an RWIS in the area is maybe reporting a little bit colder, a little bit warmer than we had in the forecast. It's actually using that to, kind of help adjust what the roadway condition is in the near term. And then it kind of goes back to forecast. So we always are taking in data. We run the pavement model every hour with all the new data that's coming in to try to keep at least those initial conditions, as close to what's actually happening on the surface as possible. Once again, sometimes if we get a little, once again, as that one site up by Grand Marais might be reporting a little cold, sometimes that can hamper the system. We do try to have some vetting to that data, but there it's probably so close where you can't determine if it's a bad observation or not. If it was way off, then you can kind of kick it out. So something to be cautious on. But yes, the forecast, I'm not going to say always changes because it may not change very much, but we're refreshing with new data all the time, running that pavement model. And a lot of it's due to when there is maybe a storm system coming through. We know you're putting chemical on the road, plowing the road, and to have all that fresh information can change future road conditions, future recommendations, as we know all that data is coming into the system where you have been out. So it continually tries to use the, newest information, freshest information, and goes from there. Joe, I see your hands up.
Hey, Rob, can you hear me?
I can hear you.
Hey, I wonder if it's worth mentioning on the road alerts where you check the road alerts, and if you hit that again, that it goes to an X. Can you explain the difference between the X and the check? Because
Sure.
it does make a difference right now as to how many roads get painted on that alert, Frost.
Gotcha. I'm going to stick in District 2 to the west here just to kind of show that. So if there's no checks, nothing there's no routes even on the system. If I click it once, put that little check mark there, now we're looking at any individual hour. And the hour is always going to be what's in the time box in the bottom left corner. If I click it again, now there's a little X up in that box. So this is the worst case scenario over the next 24 hours. So now it would highlight any road that may have that frost potential here over the next 24 hours. Now we can kind of see it's focused on the front end of the forecast, 24 boxes. So not really seeing anything for tomorrow. But that's kind of where we would see how those alerts work. And if you want to see worst case scenario, Of course, if we were expecting precipitation and we had the X checked on for road alerts, and some of the roads were going to be icy, some were going to be snowy, some were going to be slushy, then it would highlight that, whoa, we're going to have some icy roads because ice trumps snow, snow trumps slush, slush trumps wet. So it's those are how it highlights those different routes. If you're using a single hour or worst case scenario, not going to bring it up, but you can see this, same data, these same alerts in the app itself. If you use the kind of app that goes along, the WebMDSS app, and basically you're going to see the same thing. You're going to see those colors. They should be the same. You can toggle them off and on within the app as well. So if you're out and about and maybe had checked it at midnight and didn't see anything, but things cooled through the overnight, maybe a little bit more than expected. We had less clouds, or the clouds cleared out a little bit earlier. That's always the killer. If we don't have that cloud forecast just right, you get a little more radiational cooling in the morning because maybe it cleared out by midnight instead of 3 a.m. That can make a huge difference. So it's not a maybe look at the forecast at 11, especially in those maybe borderline situations. Once again, if I had a route turned on, we could, jump into the table again. And as we can see, the frost probabilities kind of built through the overnight. At 2, it was just 5%. We did get it up into the 35% here, close to 40 by 6, 7 a.m. So maybe you can watch that. Generally, I would say, from what I've seen through the years of using the program, if it's 30% or less, I would not expect frost to form. Even getting to like 40% that's kind of really borderline. If you knew you had maybe cold spots out in the area, or how we talked about maybe something near open water, maybe you'd watch those spots, but I think on the whole, you probably wouldn't see a widespread frost. As you get 50, 60%, then I would be, oh, hey, yeah, this is probably going to be a frosty night. And just kind of the way weather works, you're probably never going to see a 100% chance of frost. It's the system is, but if you're up there at like 75, 80%, which is, you don't see it much higher than that very often. That's probably almost a shoe-in, where at least from what the system has right now, that would be, yeah, you're probably expecting frost that night. So one other thing I do want to show you guys, another way you can look at maybe if there's going to be frost in the area, is we do have some risk maps. They are under your overlays. So this is where you turn on your radar or weather data. But if you scroll to the bottom of the list, just click on where it says radar, it'll pull up the menu. We do have a road frost and bridge frost probability map cover. And basically, it's looking at the next 24 hours in the forecast and showing that risk of frost. So the green areas are kind of nope, minimal. The yellows are slight. Once again, I think that RWIS sensors reporting a little cool probably triggered that a little bit. But we can see that higher chance here where we are seeing a little potential for some frost. And this is kind of state a little better chance there through portions of North Dakota. But it kind of gives you the next 24 hours. So once again, if you came in basically right at 6 a.m. and looked at it, it may give you, if you're looking for like the next morning, it still may be having the frost or frost potential from this morning. So it's probably not the best map to use at this time of day. It would be better like mid to late afternoon, or even right when you came in. You said the shift is generally 11 to 7. Look at it, maybe at 11 or right away. It might give you a sense of areas to at least watch for, where there's some potential. And even 3, 4 in the morning still probably good. As you get closer to that 6, 7, when frost could be out there, that's probably where this map is not going to help as much, only because it could start bringing in tomorrow morning's frost into it, because frost generally happens in that 5 to 8 a.m. time frame. So just a word of caution there, but at least spatially, it helps you see maybe where some frost may form. I could switch that over to bridge frost as well. So kind of the same areas, maybe a little bit. And you'll notice it's kind of some circles. So how this map works is where it has a bridge deck RWIS sensor, pavement sensor, it kind of uses those to figure out bridge frost. So basically it'll say, well, I have bridge frost here. I'll expand that out from my RWIS X amount of miles before it kind of wears out. And so you kind of get, there's not nearly as many bridge deck sensors for RWIS, so we kind of get some splotchy. Minnesota's covered pretty well, at least there with some bridge sensors, but that's kind of what it's using for the initial conditions for the model to run on frost. So that's why I kind of like to bring up the, shaded areas and or over open water, that type of stuff, because those are areas where there might not be a measurement and the weather could just be a little bit different, especially dew points right in those areas. So that's kind of the last place where you can at least get a spatial sense of maybe where frost could form or where it would be a little more susceptible for that, night or early morning. I always say, the yellows and greens, I really wouldn't worry about it. Once you get into the reds and especially the purples, that's when I would say frost is a lot more likely, but still it still may not be out there. It may be very thin where, you might not even be able to see it, but might be just a real thin layer of some frost out there. So that's kind of what I have, how frost forms, maybe the spots to look for it in certain areas, and then a few ways to kind of see it within the forecasting system. Yeah, go ahead, Michael.
Maybe you're not involved at, but the recommendations that MDSS can make, can you just kind of go into how much moisture there is in frost and how the recommendations work?
With frost, most of the time, at least when you get a recommendation, it's probably just gonna say to go out and patrol, check. There are times where you will get a salt or chemical recommendation, but that's the system probably really has to think there's a thick depth of frost on that roadway. And that, once again, I'm just going to borrow a route from out west here that has a little frost. If I go into my table view, and we can see it's this where it says dry. And if I hover over that little box pops up. And if the system was thinking that there was going to be some depth of frost on the road, it would try to accumulate that under the frost column. Maybe if the roadway was 33 degrees, 34, borderline, it might try to put a little moisture in the liquid column. But it's that frost depth that it would try to treat. So in a relatively, not a great chance of frost, it's probably just going to say, hey, there might be some out there. Not going to give you a treatment recommendation, but let's say we had a significant frost scenario where we actually have a layer of frost on that roadway, or at least forecasted to be. That is when the system may trigger to go out and put some chemical on it. It's probably not going to be very much, just because usually that frost layer, ice layer, it doesn't take much chemical to actually remove it. But the system, it's going to be, if the system basically develops frost on that roadway and that depth of frost, that's where it would come into play to recommend a chemical. Similar to if you were getting snow or ice on the roadway, it's that depth of snow that then the system is trying to remove, either via plow, via chemical. It's all in those depths right there. So that's what you can look at. Just me trying to remember a situation where we've actually given chemical recommendations for frost. It's kind of few and far between, but yeah, it would probably be on your low end of any kind of granular or liquid brine to put out there. So
that's kind of why I bring it up. I think people got to understand that you might, even with the worst frost, it's probably very thin, and
yep.
You got direct liquid or even liquid off your spinner. If you don't have a liquid truck with a pump, it's not going to take much chlorides to burn that frost off. So
no,
the application rate can be pretty low.
Yeah, I mean, if you're seeing a road that is basically pure white, and it's pretty slick, okay, maybe they're a little bit higher, but for the most times it's a very, very thin layer and would not take much. There is times where the system will track, and if it thinks there's residual salt on the roadway, it'll actually maybe use that residual salt first. And instead of a frosty road, maybe it actually tries to make it a little wet, because it's using any residual chemical that maybe it was a day after you just had an event and put some chemical down. I think one thing we kind of go off too is if you have brined or maybe pre-treated a road, frost is supposed to develop. That generally, from what we kind of go by, it lasts for maybe up to a couple days, 48 hours. So once again, it's that if you had been out there treating for another reason, some residual chemical will also kind of help, basically dissipate that frost. But as always, there could be local areas that, that frost could still form. So it's really all I had. Hopefully, if anyone else has any questions, shoot away. So once again, kind of where you can see it in your forecast.